Hey, Ham, so hi, how's it going? Hopefully you guys can hear me here. Let me check my, yeah. Yep, everything's good. I am, hopping on here and trying to find some stuff. I'm trying to find my presentations that I did. And I do not know where my presentations are. You guys see Ranger down there? Looks like somebody stole our couches. Ah, we just moved them in the other room. Hey, Bottleneck, how's it going? And so high, Code Cloud is one of the best places I think you could spend your time. Alchemist is here. Hey, how's it going? We're putting together some stuff. We got this working the other day. I'll pop up on the stream. That's fine. Um, we got this working the other day. We got it all written out, and now I'm trying to find. Man, I don't remember where I have these presentations, and I could just use one of these. But I thought that I had my presentation somewhere. I could just use one of these ones, but I thought I had started it, and I do not see it down here. Also, I'll leave it up to you guys if we want to do some networking. So I'll put a little chat message up here because I try to do stuff that you guys find useful on either side. Hold on, let me make this my stream manager. Creator dashboard, stream manager, and I'll let you guys do. We'll do a poll. I like making polls, and then you guys can decide. Networking. Yes. No. Yes, no. Let's say subnet. Give you guys 10 minutes on that. There you go, boom. All right. If you guys want to do that, if you want to walk through that stuff, I'll do it. If not, we'll keep doing what I'm working on. But where is... Man, this is bugging me. I legitimately do not know where I put a bunch of stuff, like all my presentations and stuff, every time I do my presentations with my company. Okay, maybe that's what I did with it. Let's see. Go check over here. It's still under the ProLUG presentations, but then it's over here. Okay, yeah. I guess I just called it Redline at the end. All right. So, for people that weren't around or people that are like, what the hell is this guy doing? One of my many well, I got many jobs. I got too many jobs. But my engineering company that I work for sometimes has me do brown bag presentations. And my brown bag presentation for this time is going to be on moving to the cloud. Like getting small wins, getting a smaller organization to the cloud. If anybody cares about my background in that stuff, I do have 5 of the 12 AWS. You know what? I'm going to do it like this. We'll just rename it here. And we'll call this moving. Let's see. I gotta see what the name of this is. I got it over here. So here's all my docs. Quick wins, long-term organizational strategies to move workloads to the cloud. So that's what I called it, was moving workloads to the cloud like that. And the idea is, let's see, quick wins, long-term strategies to move workloads. I'm just gonna say to move to the cloud. Quick wins. I'm just going to say quick wins to move to the cloud. And we'll do this one. This will be the red line version because that's the one that I do for my company. The one that I'll present out here and the one that I'll give to, I always put them down in our Discord. That one will be stripped off. It won't have the name Redline on it because it'll be directly for us. It's me, and it's 5x AWS. Make that lowercase. Loading. True Redline Performance Solutions, and this is going to be, it's in a couple of days, so it's technically, no, yeah, we'll do it in November. So let's save that. All right. I'm going to have to clean up, so it'll be all my quotes to get us interested. These will be changed over. I do like Deming. Deming is a great person to study if you want to do engineering and process improvement and stuff. I'm going to change that quote out for this talk, but I do love that quote. All right, so let's get down to it. We're cleaning up my presentation on this, so if we're going to do that, we're going to move this stuff over so we can see it. Some of you guys were around the other day. We put this all together. But what are your quick wins and long-term organizational strategies to move cloud, like workloads to the cloud? How do we get out to the cloud, right? And there's like a lot of philosophies. I have a talk on it where there's the 7 R's of migration, and sometimes we rehost and replatform, and sometimes we retain and retire. And there's like all these things you can do in the cloud, right? But if I came at you with an hour-long presentation on that, what would you do? You'd be like, okay, man, cool. That didn't effing help me one bit, because there's kind of like in engineering and in all applicable, let's call this like smart things that we do, right? Like engineering, and I mean, I guess even in being like a doctor and being in whatever, it doesn't matter. There's the theory side of things that you kind of need to know, but then there's like the how do we get the guy the job? And that's like the practical side of things. There's theory, and obviously like with doctors, they got to study theory for like 10 years before they even go into their residency. But it's this idea. I mean, their whole thing is 10 years. But with engineers, you have to study the theory and you have to know a bunch of things. But then you also have to like say, well, that's wonderful, but I got to like build stuff for this company, or they're not going to hire me, right? So, anyways, where I'm going with that is this talk can't just be technical. I mean, it won't help anybody. So what I'm going to do is I'm changing this up, and the topics are going to look like this. So here I'm going to do my main topics: initial setup of the cloud, right? And then the next one. So then my next major point will be focus on quick wins. I'm going to make that capital too, just because it looks good. And I'm just stealing stuff from myself the other day. We did this on stream, getting ready for this stuff. And then focus on quick wins. So one of the quick wins is start doing things you're not doing, right? The next one was let the cloud, we'll let these ones be lowercase, let the cloud come to you. And then next one is analyze existing workflows to move into the cloud. Boom. And then this last one will be long-term strategies. And that's going to be where I open up with like more of the things that are, I don't want to call them theoretical, but they're more long-term. Like you've got in business in general, you've got like the maybe the vision of the company up here, right? This like long, there's engineering topics all over this. But you got the vision of the company, then you've got like the strategy, then you've got like maybe the goals down here, and then you've got the procedures, right? The procedures are how like I actually get my hands on the keyboard and type something out to build something to go do something, right? And again, like I tell you guys, the further you move up that chain, the more you are a manager. And a lot of us, we don't want to be managers. We want to be engineers. Like I want to build stuff. I want to have fun. But sometimes we need to understand these things. After a certain point in your career, do you do prep work before interviews or just jump right in them and go with the flow? Whisper, that's a really good question. And actually, if RoboDom pops on here, I'll probably change the whole focus, because RoboDom's been one of our, like longest term kind of supporters. And he just found out that his position with our organization is going away. He actually came on and worked with my company for a few months now. And contract work being as it is, sometimes it goes away. So if he hops on or if he's around, we're going to change the whole focus and we're just going to go into basically the interview type topics. I'm going to tell you this is the way that I do things. When people ask me about interviews and such, and let's go to um, let's see if I can find my. I might have to go back here. I might even have to go back here. Hold on. I think it's. I thought I had it. I thought I called this my resume. Uh, Hold on. Yeah. So where I'm going with that, I'm going to show you guys this because, oops. What do I want to open that with? We'll open that with Chrome. That's fine. That open. So this is my resume short here, and it's funny. I don't know why it came up as Donald J. But the question was, like, what do I do with interviews and stuff? I will. First off, I have to say I over prep everything. So like I'm always kind of over prepped everywhere. Everything is a nice piece of stuff. I never remember where my stuff is. My plan going into any interview, Whisper. First off, I got to tell you, and this will, I don't know, maybe this will make it sound different. I don't have a great perspective on finding work because in the last 10 years, I've always had people come to me to bring me over to their team, and that's only because people know me. Like, people that know me and have worked with me bring me to their teams because, personality stuff aside, whether people like me or not. Oh, I gotta turn that off. Hold on. I forgot. I didn't even realize that was up in the corner. Sorry, guys. But personality stuff aside, I mean, I'm pretty easy to work with, but I think for most people. But my point in saying that is people want me on their team because I build stuff. I get stuff done. And that is one of the things I was talking about the other day about, like, even making sure, like, you don't have any imposter syndrome. If you just build stuff and focus on being good at what you do, you'll never have that imposter syndrome. And if you do, it'll be so small because you'll be like, I'm busy doing stuff. Like, I don't even have time to not think I know how to do this stuff. Anyways, the question was, how do I go about getting ready for interviews? And the answer is, I just try to know everything I can about, like, I'll review what I have on my resume because I think it's fair if I have something on a resume that anybody can ask me anything they want about it. But what I try to do is be ready to talk about any piece of it. So if I have it up here, I can tell you what I've done with it or talk about it. Like if you say, hey Scott, what's with that CISSP? I see you have one of those. What do you think that's maybe helped you with? What is that? And I say, I haven't had to use the CISSP that much, but it's kind of it's these 8 domains that deal with security. It helps us to partition off and think about security in a different sense, and it's really kind of the management standard for security in the industry. What did I learn from it? I learned greatly about how software engineering happens around security. My background is in networking and systems. I am not a strong programmer. I've never professionally committed anything to an application or something in an organization that wasn't like a system script, right? That's not what I do. So it helped me to learn how teams that I support often end up building their code and stuff. Because I'm always the platform engineer, guys. That's always been my role. I'm the guy making sure that the roads are there so that all of our applications can work on them, right? And by roads there, I mean both the networking and the system side, right? So anyways, back the question was, how do I get ready for interviews? I just generally know what's on here, and anybody can then ask me whatever they want, right? And this is by the way, in case anybody's wondering, this is a very generalized version of my actual resume right here. This is stripped off most of the stuff, most of the organizations, and while all the things I've done are the same and all the technology and other things are the same, everything else has kind of switched Augustus, you know, it's funny. I learned Six Sigma in college. I push that often for you guys and try to get you guys to do it. I never bothered to take it, so I do not have like a white belt in Six Sigma or any of those things. But it's funny you say that, Augustus. That's one of the challenges that's going to go up in our Discord soon, and that is I want you guys to go and take. Here's our Discord, by the way, in case anybody wants to go hang out in there. I want the people that don't have any plans by the end of the year to go take one of these Six Sigma certifications. There's two certifications and they're both free. So let me link this to you guys, and I'm gonna sneeze here. Oh man. Oh geez, that was a loud one. I know. My wife always makes fun of me because I sneeze so loud, and she can hear me anywhere in the house when I sneeze. They talk about this. They walk through these things, and the nice thing about this is this cert is free, and the training is free. So all the self-study training for Six Sigma is 100% free. So if anybody was like, "Hey Scott, I don't have anything on my resume," well, let's talk about that for a second. If you said, "Hey, you know, Scott, I want to like build a resume and get some things on there," I would tell you first, lead with your strengths. Whatever you think is the best thing for your role, like you've never been in IT before, lead with your strengths. If your strength is only going to be that one cert, that's fine. Put it up at the top. Then next, you know, put your experience, and then next put your college. But I would put things in the order of what kind of like the importance you have for them is. And by the way, you guys did vote to do the networking, so we'll do some networking here in a little bit. But the question that I was kind of going over a little bit was talking about, like, you know, how do I get ready for an interview? And it helps to me that people are always kind of coming up to me. That makes the interviewing process a little easier, because again, for the last 10 years, I've had everybody search me out for work. I haven't had to do the beating the street type thing, which is kind of nice. I mean, it is kind of nice to have people that you know reach out to you. But that's something you have to build over time, like to get to that. But especially if you're in the Linux world, it's such a small, like I don't want to say like, oh, I know everybody that does Linux in the Phoenix area, because I don't. But I run into people all the time in different roles and different places that I end up going, or conferences or something in the Phoenix area, that are like other Linux engineers that I've worked with over the years. So over the years, it's a smaller community than you might think, even worldwide. So, all right, yeah. So, anyways, lead with your strengths, kind of there. Get some kind of certifications. I don't care what they are. The two most free certifications I know. You know, hold on. Let me do this real quick. I've been meaning to do this. Let's grab API Academy. Let's go take our Nightbot. We'll go log into our Nightbot here, and we'll go to our commands. If you guys have never seen this done, let's just say let's add this to beginners. So beginners should definitely start here. I think that's the best place to start if you're a beginner in this stuff. Go get on Killer Coda, start touching things, but then if you're looking for free certifications to help get into the industry, start here. And then API Academy is going to be, this is programming systems there. And then I'm going to say general engineering is this one here. I've been meaning to put this into a command for a while, but let's do this. Hold on. How does that look? There you go. If you're looking for free certifications to help you get into the industry, start here. Yeah, Whisper. Send that, Whisper. Will you send that in Discord real quick so I can grab it? Because it doesn't pop up. If you drop it in Discord somewhere for me, I will. I'll get it. Let me move this stuff out of the way. Too much stuff in the way. Whisper, yeah, you said you can add one for Python. Is the Python one free? That's the main thing for these ones is I want them to be free. Um, where's that? Just put it in general if you would. I'll grab it right now. I'll pull it up and do it. If you don't mind. Any channel's fine, but general is probably best for that stuff. Let's see. Discord can sometimes take a while to come through too. That might be kind of... This one you're going to be doing? That might be kind of fun. I might, Alright. I'll add that one in there as well. This is free, like a free resource type thing. So it might go better under... Yeah, I'll put it on there. I'll put it on there. Let's add it here. And we'll throw up beginners here. Say free certifications and training. Free certifications and training. There you go, boom. Alright, good. Get that out of the way. API Academy is great, by the way, guys. If you've never seen me talk about this or walk through this, we have a nice little study guide in our Discord that one of our guys put together. They call it the Pathfinder Study Guide, and it gets you ready for each of these. Also, their training in here, it shows you, one, the certifications are free to take. The API Designer, API Security Architect, API Product Manager, all of those sound good on a resume or on a LinkedIn profile, and all of them take like 4 to 6 hours maybe of watching their videos and then passing their tests. Their tests are free, which is like, you know, the best price, right? So that's that. Okay, so we were working on, I was kind of answering a question there, and we were going off on a little bit of that stuff. By the way, Ranger Cam's up. Ranger is up and hanging out, and our couches have been stolen. No, I'm just kidding. Our couches actually moved to the other side of the house. So, by the way, I sometimes pull this up at the beginning. I need to pull it up here for you guys. If you're in our Discord, at the top left, there are events, and there are events coming up. We've got our ProLUG group later today, like normally we meet on Saturdays. Ben is going to come next week. So next weekend, Ben will be here. And if you don't know Ben, most people in the group don't know Ben, but he's a PhD candidate for over at UC Irvine, and he teaches economics and mathematics over there, right? And he's a guy that I've known for quite some time in the Brazilian Jiu-Jitsu space. He's also a combat vet. He was a 13 series, which is artillery. But he was a forward observer specifically, whereas I was like an infantry guy. So we get into a little bit, but at least he's still a combat branch. So, and then we've got our inaugural holiday Christmas party coming up as well. So there's these events that are free for you guys to come and hang out and, you know, talk shop with other engineers, rub elbows, that kind of stuff. I forget where I was going in here, but I was going to show you guys. Oh, I was going to show you guys the house stuff. In the off topic, freaking guys, this was our 12-foot Christmas tree that we just put up. And the reason I show you this picture first is this is the other side of the house. And for you guys that have been around for Ranger Cam, you guys know that Ranger normally has the couches over here by him. This is the back part of the house. Ranger always had the couches on either side of him. And then he's got the fireplace. So don't worry, guys. Ranger's very, very comfortable with his area. But we stole the couches out of there. And again, this is the 12-foot Christmas tree because the wife wanted a giant Christmas tree. And there's a whole thing there, but that's a really big one. And then the where did I put it? I think I put it somewhere else. Oh, I think I put it under here with Ranger, so Ranger Cam being back up. But this is that empty room now with Ranger Cam on him. Look how much room he's got. Ranger Ranger's a very spoiled dog, guys, in case you guys don't know. He basically guards the half of the downstairs of my house, and then he's got the whole backyard run of the, place to himself. This is the other one. This is the couches that we moved and put over in that room now. So, pretty good little setup there. The kids and the nieces and nephews love it, so it's pretty good. And then, of course, if you guys don't know this already, I'm kind of a bit older, and I am technically a grandpa. Not technically, I am a grandpa, right? So, anyways, the system stuff. Got our monitoring up. We're back on our normal network, right? Had to deal with Cox Internet for quite some time about that. But okay, you guys voted a little while ago and said let's do some networking. So I'm going to pull up the networking. And if you guys have never seen this is my way that I've been teaching other engineers and college students networking for quite some time. I put a gradient on it because people are always complaining about it being in white mode, like too bright. So I made it a little darker. And let's pull up my Epic Pen. Epic Pen is a free little tool. If you guys haven't ever used it, it's probably like the best way to, let's see if I can get it to pop up here. There it is. Epic Pen's like the best little way, I think, to annotate on pages. And you might say, well, couldn't you just use the PowerPoint one? Yeah, the problem with PowerPoint is you got to jump into presentation mode. And once you go into presentation mode, like PowerPoint takes over your system. So screw all that. I don't want to do that. Let's go ahead and make this. We'll go back to black because I think you guys will be able to see that just fine. And we'll go to this. And the point of this document here is to kind of walk through. So I'll go with the first thing I hear. But do you guys want the very, very basics of subnetting first, or do you guys just want me to jump into subnetting? Like, do you guys want like the number theory behind all this first? I do that some streams, but sometimes I think people probably find that a little bit too basic. Not too basic, it's just like if you've already went over it, then maybe you're like, screw it, I don't want to see that stuff again. Same thing with my college students. I go with the first thing I see. So whatever you guys tell me to do is what I'll do. In the meanwhile, I will post something. I will just write something right here. Quick refresher. All right, Bottleneck. We'll start with the absolute ABG, absolute beginner stuff. Let's start back here on number theory real quick, guys. This is going to go back to like 6th grade real quick for you. And you say 6th grade? Yeah, I don't know exactly where anybody went in, to grade school here in the U.S. or around the world. Might have been earlier. I would imagine it was earlier in some countries than the U.S. I'll pop myself back up here. But we're going to talk some real quick number theory, and also we'll pause for the commercials because it looks like there's commercials that are going to pop up here. But if I came right here and I'm just going to start writing some stuff here. And then I'm just going to go 1, 2, 3, 4, 5, 6, 7, 8, and 9. I'm just going to draw all those right there. And then I'm going to come over here and let's take a break real quick for the old ads here. We'll let the ads go and we'll keep an eye on Ranger Cam real quick. All right. Yeah, and then Bottleneck, we'll get back to it. So it looks like people are on a break here, I think. So I'll give you guys a second, and then there's ads on the Twitch side. On the, let's see if I can go back to my channel content. Let's see if I can go back here and actually watch myself over on I want to watch myself on the Amazon side. Okay, or on the not Amazon, on the YouTube. All right, there we go. I'll make these things flip over too. All right. I think ads should almost be done. I don't know why ads stopped popping up, but there should have been an ad, and hopefully it's all done for you guys. But we're gonna come back over here, and I'm gonna keep drawing on this. And real quick, if I were to ask you guys, now the ad starts. All right. 2 minutes, guys. 2 minutes on the clock. We'll go watch Ranger Camps for a second. 2 minutes. 2 minutes. We'll let the ads run for the people that are watching ads real quick. Also, there's one other thing about that I found on the ads on Twitch is they are not synced with what it tells me. It tells me that we're on an ad break and we got a minute 26 left. But for any of you guys that are watching, I'll have people say, "Oh, we're back," but it's like 20 seconds off, and I'm like, I don't even know why they bother telling me that kind of stuff. They should just let me go. But I'll let the ad break go. It's got another minute, and our monitoring's back in place. Everything's going. One of the things I was gonna do today, and whether I do it on stream or off stream, I'm gonna be working on the ProLUG lab. I have some procedural stuff to make the lab better, and I want to get to using KubeVirt to make it look a lot more like our. We do a bunch of labs up in Killer Coda, so if you guys have ever seen Killer Coda, it's a great place for labs, and I kind of want to make our ProLUG labs look kind of like those labs, except in those labs there's a bunch of things that we can't do, and they're never planning on giving them to us, like additional disk. Like I want to give you guys disks and have you guys carve up disks inside of Linux, but we can't do that in their lab. So I just need to work on it a little bit and get our lab kind of up to that level. Our lab does all kinds of other cool things, and if you're a part of the ProLUG, you can get into that lab. It's just our lab environment is more of like you have to kind of spend your own time and learn your own stuff in there. So, okay, let's go back to this. This is where we're at. This is what people, the people wanted it, so we're doing some networking. And I just drew a number up here. This number is not related to the conversation here. Hey, thanks for stopping back by, Andre. Hopefully this stuff's useful to you. So real quick, let's look at this number right here. And let's say you have that many. I tell you right now, you have that many dollars in your wallet. I don't know, right? It's a lot of money. 786. Now, you probably use that number all the time, so you've never thought about it. But there are 10 states of nature that each of these numbers can be in. Each of these positional holders here, each of these places. So if there's 10 states of nature that it can be in, we call it a base 10 numbering system. What that means here is that we can represent any one of these values in that place, right? And again, most of you probably do this. You probably learned this very early on. You probably do this instinctually or non-intuitively because you're so used to doing it. But I got to step back for a second to be able to then show you the binary part. So this right here is 10 to the power of 0. And anything to the power of 0 is 1. So this is the ones column. So, even though this is 786, this is this is the ones column. So this means that there are 6 ones. This is 10 to the power of 1. Anything to 1 is itself. So this is the tens column, right? And then 10 to the power of 2, 10 times 10, is the hundreds place. So this is the placeholder for each of those things. So now we can look at that same thing that we just looked at and say, truly, there are 7 100s, there are 8 10s, and there are 6 ones. Does everybody kind of get that? I mean, I get that this is like stepping all the way back in number theory to something that's probably like from like 6th grade or maybe even like 4th grade, depending on what state you went to or what state grade school you went to or private school. Maybe it was even earlier. I don't know. But the point is, that is our numbering system that we use. But then we come down here to binary, and the only thing we have is a 0 and a 1. So we've got a 2-base numbering system. This is our base right here. It's a 2-base numbering system. It's a 0 or a 1. Those are what we call the states of nature that we can represent here. So I could have any number here. I could have a 1, a 1, a 1, a 1, and then a bunch of zeros. And those would be representative of there is a 128, there's a 64, there's a 32, and there's a 16. But there's no 8, no 4, no 2, or no 1. So this right here becomes 240. This becomes the number in decimal for us, 240. And you say, well, how'd you do that? Well, I added 128 plus 64, which is 192, plus 32, which is 224, plus 16, which is 240. And if you go, Scott, I couldn't possibly do that in my head that fast. Don't worry, I already knew the number. I didn't. When you do these guys, there's only 0 to 255. When you do this long enough, which is like 21. Actually, I've been learning it for 23 years, but 21 years out in the industry doing it, and that's when I passed my CCNA, was 21 years ago. There's only so many combinations of this, so eventually you start to learn all the numbers. Well, that's 240. The other way to look at it is it's 15 less than 255, which is all the way at the top, right? So there's different ways to do this, but I don't want you guys to learn the shortcuts. I want you to learn the basics of this. So that was like the base number theory stuff, right? Before we get into the subnetting part of it. So let me clear this off. These things don't need to be here. And this was a refresher, so this doesn't technically need to be here at all for us to talk about subnetting and kind of how subnetting works in general. So we've got some network here. This is some network. 192.168.11.0 is the network. And let's break down how this network works. In the first octet right here. So they're called octets because there's 4 bits. Or sorry, 8 bits. 8 bits. 8 bits. And 8 bits. Oops. These bits, I can draw. These bits are represented by the numbers 0 to 255. So that's the most you could possibly have. 0 is all of these bits off. 255 is all of these bits on. Those are the states of nature. Those are the values you can have for these as we move forward. So we got a 0 and a 1 that we can use in here, right? And then the numbering system follows the pattern that we just learned, where this is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and you keep going up, and those are the numbers that go with it. So why do I use this template? So you might ask, like, hey, Scott, why do you use this template to teach this? Well, because no matter what comes out of the gate, no matter what they ask you on a Net Plus or a CCNA, if you understand this part, you could draw this out real quick and find the answer. So let's look at this like a question that somebody might ask us. They give us this. By the way, this is a default /24, and I'll show you how to find that in a second. But let's say they tell you it's a /28. What the heck does that mean, right? Like, what does that mean to be /28? And then they ask you how many, I'm just going to say HM, how many subnets? How many subnets? They ask that as a question. And then they say how many hosts per subnet. How many hosts per sub? And they ask you these 2 questions, and you go, all right, I need to get this. And by the way, most of the certification tests aren't going to ask you stuff directly like this. They're going to assume that you know this, and then they're going to ask you a question. You say, that sounds really effing hard. It is. Like, you have to, I don't want to say you have to do this like you breathe, but you have to understand this, right? Yeah, so let's talk about this real quick. So the idea here, when I say it was a /24 to start, but they give you a /28, this is the idea. Let me pull up another talk real quick that I have that shows this. This comes from another thing. I'm gonna give me 1 second to pull up this other thing. This comes from our primer, and this is our networking primer, and we did this a while back. This is actually up. I added this on our this is on YouTube. If you guys want to go watch our YouTube and say, hey, you know, Scott, I need the primer. I need to know all this stuff. This was my primer back on September 30th. This is up on YouTube. This will be there forever. But this was presented to the Professional Linux Users Group. I spent about 3 hours going deep into networking. Deep, but really it's just like scratching the surface of it. And down here, I want to show you guys this. Why do we subnet? Well, the network we were just given is 0 to 255. It's this big, giant open room. And we can yell in this room to everybody in the room, right? When we broadcast to .255 in that network. 192.168.11.255 is the broadcast. And if I was standing over here, and all of you were over here, when I broadcast, I would broadcast to this whole big wide room. But there's only, there's 15 of you here watching and then me. So if I'm yelling over in this corner, there's all this wasted space. What if I wanted somebody else over here and they could talk to their classroom, like their teachers or something? Well, this room doesn't work because now when I yell, all of their students here, and when they yell, all of my students here. So this is the network we're given, 192.168.1.0 in this case. That's 256 total addresses. Now you got 254 usable because the network name goes away and the broadcast goes away. So that's where the -2 always comes from. And we've got this big network. But I need to mathematically break it down to be smaller. So this is something that I wrote. But you want to carve that big network up, so you borrow 1 bit. Now you've got a /25 for the networking address, and you've cut this room into half. The first network is 0 to 127, and the second network is 128 to 255. Here's your network address for both of them, and here's your broadcast for both of them. So when I'm up here and I want to yell to my students in here, I yell at .127, 192.168.1.127. When this guy down here wants to yell at his students, he yells at 192.168.1.255, and only his students hear his part, and only my students hear this part. If any of you ever been in one of those big ballrooms at like a Marriott or a Wyndham or something, and they've got those big conference center rooms, and they can keep dragging the walls out and making these smaller and smaller rooms for like little subsections and stuff, that's what the subnetting stuff is. So now, we go and we say, let's borrow 1 more bit. Well, if you borrow 1 more bit, you don't get 1 more room, you get 4 rooms. Because you made 2 precise same size cuts of that network. So now 192.168.1.0/26 has 4 networks. The .0, the .64, the .128, and the .192. And because those are all individual rooms, as it were, networks, they have 4 individual ways to yell at each of their rooms. So .63 yells at this room, .127 yells at this room, 191 yells at everybody in there, right? And you say, really, yelling? Yeah, that's what a broadcast is. A broadcast says, all stations this net, listen. It's like the old military thing, right? All stations this net respond in order or whatever. That's not what it does in networking, but that's what it's like in the military. And then I say, well, what if we carve it again? So we borrow 1 more bit. Now we've got 3 bits to count on. And when we do that, we break it up into 8 networks of the original size. So I'm going to carve this up, and I'm actually going to go 1 further. And we're going to carve this up to be, there's going to be a 0 to 31, 32 to 63. I'm going to go further. It's going to be 0 to 15, 16 to 31. We're going to carve this up even further. Maybe I'll add 1 to this so it goes even further. And then this is my, in the example. Again, if you guys want to see this done, there is a YouTube video on it, so go feel free to watch that if you want. But we're back here. Let's open this up, and we've got a /128. So real quick, the first thing we need to know here is this a Class A, a Class B, or a Class C network? There's also a D and an E, but you will not run into that in normal networking. D is multicast addressing, and E is experimental. But let's do real quick. Let's look at this 192 in the first octet, and then I'm going to give you some rules. Between 0 and 127, 126 really. Yeah, there we go. It's Class C. How is it Class C, though? 0 to 126, we'll say, is going to be your Class A. 128 to 191 is going to be your Class B. And 192 to 223 is a C. So we know this is a Class C address. Let's call that a Class C right there. Boom. So what does that mean? That means that the Class C, the first 24 bits... That's 8 bits, 8 bits, 8 bits. These here, to the left, all this over here is the network. Okay? So this is the network here. Everything to the left. And you say, well, Scott, what do I need to know about it being the network? Let's just say for now, and by the way, it's going to be right there as well. Let's just understand that the network, for all intents and purposes, as a beginner junior engineer, the network is given to you and it is set in stone. It might as well be your height. You're not going to change your height no matter how much milk you drink or whatever. Well, let's say when you're an adult. It doesn't matter. And who knows if it matters otherwise. But the point is, once that's set, that's set. 192.168 is the network you're given. I can't say, but keep the tab open. Musa, I appreciate it. You're always welcome to hang out. Lurkers are the backbone of Twitch, so I appreciate any of you guys that can. I mean, honestly, any of you that can listen to my voice for more than a few minutes, I'm impressed with. I tell you guys all the time, like my students have to listen to me. You guys here, you don't have to listen to me, right? All right. Hey, thanks for the follow. The mind sign. Hopefully, this stuff's useful to you. We are doing some subnetting, and we're talking about how the network is something that you can't change. Something you can't change about yourself. It's your height. It's your shoe size. Like you can't really change that. All right. Although it's funny in shows and stuff when they try to. I don't know if you ever saw the IT crowd, but she's trying to wear the shoes that are like 3 sizes too small for her big feet. It like caused her to black. It's funny. Anyways, 192.168.1.0. I'll pop back up here because we don't need the bottom right just yet. So just know that the bottom right's got some information that's covered like all behind me here, but it doesn't matter to the talk right now. So then I said there's a /28. So /24 was the network you were given, but somebody in your company, somebody before you, some senior architect, some network guy, whoever, all her toes are, she's got like these snaggle feet, and so I do this sport called jiu-jitsu, guys, like Brazilian jiu-jitsu, and we're always wearing our sandals and we can always see each other's feet, and we always joke around about how I joke around about it, if your feet look like you can swoop down on a lake and catch your food for the night, like an eagle, if your feet look like that, you shouldn't be wearing sandals, right? But real quick here, hold on, we've made this was 24 network addresses, 24. Guys, I'm the worst. I'm so bad at. I hate drawing with my mouse. So 24 network bits. Now you borrowed 1, 2, 3, 4 subnet bits. So these are 4 subnet bits right here. That's what these all are. Let's get that out of the way so it doesn't confuse anybody. And that leaves us with 4 host bits. Does everybody see how that math is mathin'? There's 32 total bits across the screen. Let me erase me real quick. There's 32 bits total across the screen. So if your network bits were 24 and you borrowed 4 for subnet bits, you could do the math with some simple algebra and find your host bits, which is also 4. So this is a simple little equation here that I add as part of this when I'm showing people this and teaching it and stuff, of how you get to 32 bits. And you say, why is it 32 bits always? Well, because that's the standard that's defined by the IPv4 subnetting, right? IPv4 subnetting is 32 bits long. That's 2 to the power of 32, so 4.3 billion addresses total for both your sender, your destination, or your source address, right? So let's go over here and let's do some quick stuff real quick. I said, how many subnets are there? And you could count them up here. I'll show you how to count them up. But what you could also do is I've got an equation down here, which is 2 to the power of s is your number of subnets. So 2 to the power of 4, 1, 2, 3, 4, there's 4 bits, so 2 to the power of 4, I can come right here and I can say 16. There are 16 subnets here. But you say, Scott, can you count them? Yes. It would be 0, 0, 0, 0, and then I would add a 1, 0, 0, 0, 1, then I would add a 1, 0, 0, 1, 0, then I would add a 1, 0, 0, 1, 1, and you say, how do you know where to add a 1? Well, when you add a 1 in any numbering system, you always do it on the far right side. It's in the ones column. It's right there. That's how you add a 1, right there. So now this one, what's the next one? 0, 1, 0, 0. What's the next one? 0, 1, 0, 1. What's the next one? 0, 1, 1, 0. Now when you look at this, and you go, wait a minute, Scott, but aren't you counting by the 16s column there? Yes. So what are the networks? The first network is the 0 network. The next network is the 16 network. The next network is the 32 network. The next network is the 48 network. And you say, and what does that network go to? Well, I can cheat. I can say 1 less than 16 is 15. I can say 1 less than 32 is 31. By the way, if I go pull this other one up real quick, hold on, watch this. You're going to think I'm doing sorcery here. Let's go back to this. And isn't that what we just had right here? Is it? Well, actually, sorry. It's half of this because I went further. I'm on the 128, so I carved all these further. But 0 to 15, 16 to 31, 32 to 47. So all of these things, they line up. They're the same. We're doing the same thing, guys, right? But this is mathematically how it works. Now, the question then is, how many hosts per subnet? Well, 1, 2, 3, 4. I've got this equation, 2 to the power of h minus 2. So it's 2 to the power of h, 16, minus 2. So there's 14 per. And you say, Scott, why is it 14 per? Well, let's go look at that real quick. We have to subtract all zeros in the host bits. When you have all zeros, that's the network. And when you have all ones, when you turn them all on to ones, that's your broadcast. Remember I told you guys broadcast is like yelling at everybody? That's it. That's all of networking right there. That's all the subnetting that you need to know to be able to pass most of these tests. But typically you've got to spend a little time. You got to let this cook, right? So let's say that the goal of this real quick is to kind of learn this and see a few examples. I'm gonna wipe this whole screen, and I'm going to wipe. I'm gonna come back here real quick, and where's this other one? Let's go here. Let's do this one. So you have, and we'll flip back and forth between the visualization of this and this. Does that sound fair? So the visualization of this, we're going to say 192.168.1.0/27. It's going to give us 8 networks, and these are the networks. And I'm about to do it mathematically to prove it to you. Does that sound? I think that's more than fair. This is the same way I show this to my college students. I've been showing this to engineers for 20-something years, and I've been teaching this at the college level. In fact, in 5 days, in December, I will have been teaching college for 15 years, right? On this same exact subject, right here. All right, so let's go back over here. We're gonna do a 192. This was the number 192.168.0.1, let's say, and it was a /27. So now I'm gonna be able to just flip back between these like this, and show you guys 192.168.1.0/27 will have all of these networks. Let's do it. Open this back up. Let's change that to a 0. We're gonna do all the same things we did earlier, but I'm gonna break it down a little bit and make sure that everybody understands. We're gonna do a process here that I didn't show earlier, but I think you're gonna pick it up quick. Here's a 192. I want to take this 192 in decimal, right? Decimal is a 10-base numbering system, and I'm gonna turn it into binary using this. So I'm gonna start at the left, and I'm gonna say, does 192 have a 128 in it? And the answer is yes. So I'm going to subtract 128. 128. That's going to leave me with 64. Does everybody see that? You could get your calculators out if you want. You've got 64 left. So now we're going to add, is there a 64 and a 64? Yes. Now is there anything left over? No. This number in binary is that right there. That's the number. Thanks for the follow. Who's a dem? Hopefully this stuff's useful to you. Or who is Ozdem? Hopefully this stuff's useful. Now 168, we could do the same thing. Is there 128? Yes. That leaves us with 40. Is there a 64 and 40? No, there's not. Is there a 32 though? Yes. That would leave us, if we have a 32, that would leave us with 8 left over. And then is there a 16 and 8? No. Is there an 8 and 8? Yes. There's no 4s, no 2s, and no 1s. Now this one is 0, so is there any 128s and a 0? No. Are there any 64s? No. Are there any 32s? No. This is our template down here. Are there any 16s and a 0? No. 8s, 4s, 2s, 1s? No. No, 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 no. Right? Okay. So then how about 0? This one's 0 as well. 0, 0, 0, 0, 0, 0, 0. All right, so we broke that whole network down. Boom. That's decimal to binary conversion. You start at the left and you flip switches on based on whether or not they fit. That's exactly how it works. Anybody that tells you it's more complex than that's probably trying to sell you something. The screen went black. Can you guys not see me? Bottleneck, refresh, bottleneck. It said I went to commercials again. So you might want to refresh real quick. I'll give it a second because it does say we're on ads, guys. So let me give it 1 second real quick. Go back over here while we're waiting. See how Ranger... Oh, look at that Ranger dog. Ranger has... his couches have been stolen. He doesn't have his couches anymore, guys. This is the privileged life my dog leads. Downstairs all by himself, 2 beds in front of the fireplace. But it's like it's getting down to like high 50s Fahrenheit at night here in Phoenix, so it's like exceedingly nice here, right? Like, yeah. Okay, Bottleneck, you're back. Okay. We're going to go back to exactly where we were, guys. I stopped while we were on that. I'm going to actually, we'll give the next 30 seconds real quick because it says that some of you guys are still on break. So let's give it a second here real quick before we move on. And I'm going to walk through, and again, we're going to make sure that we build the exact same thing that we just showed over on the other thing. And I'm going to flip back and forth between them when we're done here. So you guys see that I'm not lying to you. There's literally nothing up my sleeves. I am just doing this as base math, right? And we have to do that because there's no other way to do this. So, all right, real quick, it's a Class C. We know it's still a Class C. That means it's got 24 network bits, which makes it easy. Nothing to the left ever changes. So the mask, by the way, the mask is underneath me, but the network bits, whoops, there we go. The network bits are 1s. So the network bits are 1s. So all these network bits gets 1s for the masking. Let's just do the whole thing so we understand. And the base net mask that we were given with this, if somebody were to ask us, is all those are going to be 1s. So the base net mask for this is 255.255.255.0 to start. But we have a /27, which means that somebody in our network borrowed these bits here. And these bits are subnet bits. And by looking over here, I see that subnets become 1s. It's just a rule you need to know. And then the host bits become 0s. So the subnet mask of this, if I were to have to put this into a computer, would be 224. And you say, Scott, how the heck did you get that number? Well, because it's a 128 plus a 64, which is 192, plus 32, which is 224. So the subnet mask of all networks that have to do with 192.168.0.0 with a /27, all of the subnet masks for all of these networks is 255, 255, 255, 224. Now let's count up the networks. The first network is the 0.0.0 network. The second is 0.0.1. The next is 0.1.0. The next, we're just adding 1 each time, 0, 1, 1. The next is 1, 0, 0. The next is 1, 0, 1. The next is 1, 1, 0. And the next is 1, 1, 1. Does anybody fault my counting? It's okay to fault my counting. Maybe I did it wrong. Pop myself back up here. It's okay. Sometimes people count wrong. But in this case, I have 1, 2, 3, 4, 5, 6, 7, 8. That's what I expect. That is part of this line here, right? This line that was dashed to show you that we did it ourselves. And now, if I look here, 1, 2, 3 columns in, and I move over here, do you guys agree that I'm counting by the 30 seconds place? So the first network here, the first network we have is 0. The second network we have is 32. The third network we have is 64. And do you guys see how I'm getting those? This is the 0 network because there's 0 in the subnet bits. This is the first network, which is the 32. Bottleneck, I graduated over a year ago, and I've never seen this explained so good. Bottleneck, I've been hearing that for 15 years. This is the way I go down. I have buddies that teach around the valley at high schools for their cybersecurity programs for some of our different things, and they have me come out every year and talk about this. In fact, I've had a request to just take this and put just this as its own little subnetting thing on YouTube. So I might do that one day. So wait, you put yourself on the 30 seconds. Well, yeah, so because we did a /27, so we borrowed 3 bits. The base networking of this network was a 24, remember? The network that we were given is 8 network bits, 8 network bits, and 8 network bits, which was 24. And then somebody in our network borrowed, and the reason we borrowed, hold on, there's a question here, and this is important. The reason we borrowed is because we wanted to do this to our network. Because everybody always says, oh, just subnet it, or oh, we subnetted the network. But this is why I'm trying to tell you guys. This is why we subnet. The base network was this. It was just a big room that we could all yell in. And when I yelled, everybody heard me. And when you yelled, everybody heard you. And it was not efficient networking. So what we did is we carved our network up. We said, I'm going to take, you gave me that hard /24. I can't change those. Those are set in stone network bits. And I had 8 of my host bits to do whatever I wanted with that big network. I purposely chose to take 3 of those and carve them down, turn them into hardened network bits that can no longer change. That's the /27. And by doing so, by me doing that to my own network, I put these walls up. So now we've got these individual little rooms that people can yell in. That's all it is. The goal of subnetting is to break up broadcast domains. It breaks up how loud you can hear me yell across the organization. That's all it is. So watch, just hold this in your head real quick. I had this, and I carved it up mathematically to be this. If you remember that, this over here makes more sense. Watch. We had this, a /24, 192.168.0. That was our big network. We could yell at 192.168.0.255, and everybody between 192.168.0.1 and 192.168.0.254 would hear us in that big giant room of networking. Now again, we're representing it as ones and zeros, so we kind of have to see it in our head from that other drawing. But we said, hold on, we need to make these partitions. We're going to break this room up mathematically like I just showed, and we did it right here. Well, when you do it here and you count 000, 001, 010, 011, now these are your networks. And when we go to convert them back on counting on the 30 seconds place, now you get the network 0, the network 32, the network 64, when all of these are zeros. Now, what happens when I turn all of these are my host bits? When I turn all of my host bits to ones, so I say all the hosts are on, that's my broadcast. That's the 31. So these networks exist in this space here. By the way, I can cheat. I can just go up one side and then count back down the other side. So that's the 64s column. This one is the 96. Oops, this is 96, right? This one is 128. This one is 160. And we could keep going all the way to the top if we had space. The next one would be 192. And that's as high as we'll go here. Let's just for completeness, the very last one is 224. 224. Those are 1, 2, 3, 4, 5, 6, 7, 8. Those are all my networks. Now, what's the broadcast? Well, the broadcast is when you take this subnet, and then instead of having all zeros in the host bits, these are my host bits, right? All the host bits, they become ones. So when they're all ones, we're yelling to everybody in that network. Well, the first one is 31, but here's the trick. We know what the top one is. We know that the highest we could be is 255. So in that last network, it's 255. But then the one down here is one less than the other one. So this is 223. This one is 191. This one is 159. There's one less than the one before it. This one is 127. And this one is 95. Now, lest you think I'm doing some sorcery here, let me show you guys. I do not have anything up my sleeves. I predict that all of these numbers that we just mathematically did right here line up exactly with the ones on my presentation over there. So watch. Look, nothing up my sleeve. I'm gonna close the eye down here. Hold on. I'm gonna pull this up. They all align perfectly. We did it mathematically, but it's the same way that I carved it up. By the way, I got this from that, not the other way around, right? This is just the visual representation of a mathematical concept that we just looked at. So if any of you were like, I didn't think I was going to be learning any math this morning, well, there you go. Boom. This is subnet. This is how network works. This is how networking works. So we subnet, we carve up our own network. We do it to ourselves. We actually lose bits. We actually lose usable host numbers by doing this, but we make the network itself more useful. By the way, this is all fixed length subnet masking. I haven't even shown variable length subnet masking. I need to add that to this presentation one of these days, but we can carve these up as sub portions of each one as well. So, all right, so that's how that works, right? Let's pull this back up, and what other things might might somebody ask from this? So they might ask how many subnets. Well, you got 2 to the power of 3, so you got 8 subnets. We can also count 1, 2, 3, 4, 5, 6, 7, 8. Boom, good. How many hosts per subnet? That's 32 minus the 2, so it's 30 hosts in each subnet. And that tracks because the 0 is unusable, so I can start at 1. And 31 is unusable because it's the broadcast. That's where you yell at everybody. So the usable hosts of this first network is 1 to 30, which is 30 total, which is the mathematical number that we got right here. Like, it all points to everything else, and you really just need to learn these rules. Oh, I keep showing things that are behind myself. I apologize, guys. So let's do this. I will tell you guys this. Some of you are probably tracking this a little more than others, and some of you probably want to see it a few more times. So I'm going to just tell you this. Give me any network. Go out on the internet and say, what's the hardest thing to subnet? You know, give me a class A, or say, give me a class A or a class B. This is a class C, widely regarded the easiest. Give me any subnetting you want me to do, and I'll do it. I will do it, and it won't even it'll be effortless. Because this system, right, and I'm not bragging, I'm telling you, the system here works for any number set that we want. You guys want to see me, like, carve up a big network like I would for an enterprise or something? This stuff is, it's all it is bigger numbers around the things that you're doing base. By the way, if you're like, well, where would I use this stuff? Well, the other place we use this all the time. Let me pull this up for you guys. Hold on. Let's pull this up. Let's go to my. We'll go to my. Let's go to my Amazon console here, right? We'll just go in. I did this the other day for you guys, but I'll pull it up again. Maybe you guys want to see. Get down into my VPCs, right? That's a big part of it. Yeah, so VPCs. Let's look at my VPC right here. This is my virtual private cloud, one that I built the other day just for a project. We were messing around, and let's look at my VPC where all we know is this right here. 10.100.0.0/16. That's the smallest. Sorry, that's the largest network they'll let you have, even though in your home network or in your company network you could go bigger than this. But the biggest they'll give you in the cloud is 65.534. Well, 65.536 minus 2. But then we could come down here and we could look at each of the different networks, but they broke them down as a /20. So I'm gonna use this right here. 10.100.0.0/16. Let's do that. So right here, I'm going to open this up. I'm going to delete all this, and I'm going to say 10.100.0.0/16. That hold on. This was the network this is the default network. The network that all of my subnets went off of was 20. So let's do this. Let's say, hey Scott, can you do this? And then go back and reference the way that it was carved up in the cloud, and are the numbers going to match up? Does that sound fair to everybody? Does that sound like, I think that would be a good proof that this method works. Well, the method either works or it doesn't, but I think you can see that real quick. So let's do this real quick. Whisper, I've got some good resources for that too. How we break up a VPC for like public load balancer and backend. Actually, I'll show you this as that here in a second, where we would place the load balancers and that kind of stuff. But let's do some quick basic exercises. This is a 10. So do we all agree that I'm dealing with a class A network? Class A, right? Because it's 10 in the first octet. I think you guys should all probably give me a thumbs up, or give me one of those do all the Linux. I think you will need CIDR for that, not the classical system. Andre, yeah, we probably would carve these up further, but it's fine to leave things all in one big network if you want to. That's very possible. But okay, so let's look at this real quick. We agree that this is a class A, so the basic cut would have been here, but the way they give us inside of the cloud is never passed right here. So you will never touch anything to the left of this. So we've got 16 total network bits. These are all network bits right here. We can't touch them. But let's still break them down just for fun. Let's do a 10, and let's take 10 here in decimal, and convert it down into binary. So we're going to do it like this. Does 10 have a 128 in it? No. And by the way, some of you are probably like, Scott's being silly. Scott's going over this. Somebody needs to see this until it snaps. And once it snaps, they never need to see it again. Some people, you saw it the first time. It's like I keep showing you the same magic trick, and one day you're going to be like, and it may be the first time. Some of you are probably smarter in here than others. That's what happens. I always tell my college students, it doesn't matter how smart you are, right? Like, it matters what you can build and what you can do. So if you picked it up the first time, just bear with me while I keep showing this to people, because I didn't get this the first time, guys. This takes a while to work on. Does a 10 have a 64 in it? No. So again, some of you probably think I'm being silly, but some of you still need to see this. Does a 10 have a 32 in it? No. Does a 10 have a 16 in it? No. But does a 10 have an 8 in it? Yes. Yes. And then what's left over? There's 2. So there's no 4 and 2, but there is a 2 and 2. So no 4, but there is a 2. And then there's no zeros because there's nothing left. By the way, 1010, if you just looked at this side of it, is a hexadecimal A, right? A is 1010 in binary. So as you start to look at these, technically you can represent these as, 8 hexadecimal numbers. We don't do that because that'll confuse people, but you could. Let's do 100. Does 100 have a 128 in it? No, it doesn't. It's too small. But does it have a 64 in it? Yes. And then we've got 64, so 36 left over. We got to turn the 64 on. Is there a 32 in that? Yes. And then with 32, you've got 4 left over. So is there a 16? No. Is there an 8? No. But there is a 4. There's no 2s and no 1s. So 100 from decimal to binary looks like this: 0, 1, 1, 0, 0, 1, 0, 0. And you might say, well, my calculator left that 0 off. Yeah, because your calculator's not constrained with needing 8 bits like a frame or like a packet for IP is, right? So I want you guys to think about that. And then a bunch of zeros there. All right, so in my subnetting, we got to prove ourselves, right? I said we're going to prove that this works according to the way AWS has it. We're going to flip back over to the AWS side. They gave me a /20. Most of my subnets are off of a /20, which is, if this is 16 right here, that means that I have 1, 2, 3, 4 bits that I can use for subnets in this VPC. Right here. And then that means that over here I have 12 host bits. So any of my subnets could technically have 4094, right? I got to take 2 off of addresses in them. But let's count up all my subnets. How many subnets do I have, by the way, by default, without getting into variable length subnet masking? 6. So SSSS is subnets 2 to the power of that. I have 16 usable subnets there. Let's see if I can count them all up real quick. Well, the first one would be 0, 0, 0, 0. And the last one would be 1, 1, 1, 1. Right? And then we would have all the places in between there. So, the ones, real quick, we'll just draw the ones that we can. 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1. Let's make that down there so it's very obvious it's not one of these. 0, 1, 1, 0, 0, 1, 1, 1, and then 1, 0, 0, 0, with the pattern repeating up there till we got to 1, 1, 1, 1. Does everybody kind of agree with that? Now, if we were to look, we can see 1, 2, 3, 4, 1, 2, 3, 4. We're counting on this one right here. So we're counting on the 16s place. So all the possible so if I were to take those and list out all 16 of the possible things that could be there, all the possible networks, I could have the .0 network. I could have the .16 network in this octet. It would still be 10.100 over here to the left, and then it would be .0, .16, .32, and then we're counting by that, so 48, right? Then .64, is that right? Sorry, .48, and then, yeah, 64, right? And the 64 one is right there, so 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, right? Do you guys see that? Recommend to pattern for all numbers between 0 Bottleneck. I mean, it depends where they're at, where they're borrowed for what the numbers actually are. So I would just recommend you know this. You got to know this because if this had been one more over, we'd have been counting at the eights, and if it had been one more over, we'd been counting at the fours. If it had been down here, we'd have been doing the same thing. So I wouldn't tell you necessarily to memorize them. I would just tell you to know this, and then practice converting them over. And after time, you're gonna start seeing them more. This next one will be 96, and then the next one will be 128. Those are the networks down here, and then we'll keep going. So the next one, if we add 32, that's 160. Yeah, wait. Oh, we're counting by 16s, guys. I'm messing this all up. Sorry. I'm messing this all up. 16. So we're adding 16 each time. So 16 from that is, that one should be, we got an 80. I messed it all up, guys. 96. What is it? Is it the next one 112? And then 128. I messed it all up, guys. I apologize. Now, on the other side over here, after 128, we're going to keep counting up, right? 16 more than 128 is what, that 144? Right? 168. No, sorry, 160. That just keeps getting worse. Every time I draw stuff, it just keeps getting worse. All right, so that's 160, 176, 192, and then we should have 208, 224. That's 224. And then we should have 240. And 240 is the last one. Okay? Hey, Kokas, how's it going? We're just going over subnetting. So wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's all 16 of them. Now, real quick, if we believe that to be true, that those are all of them, let's go check real quick all of my networks inside of the cloud. If I know that it's a /20, here we go. There's the 0. That's the first one. There's the 176. That should be one of them. I learned 1 hour than an entire college course. Yeah, Whisper. I'll tell you, I had some really bad college classes when I could tell you guys stories about that. Like, I think I've told some of you guys before. Like, I went to DeVry. I already had my CCNA. When I got out of the Army, I already had my CCNA. But they put me in these classes. They only took 14 of my 49 credits. And they put me in some basic, like, remedial, like, not even remedial. They were basic Cisco classes, and I could have taught those classes. And there were people, and that's why I tell you guys, like, I say this all the time, and people don't want to believe me, and I don't care. College is, you're going to get exactly out of college what you put into it, just like you're going to get out of the gym exactly what you put into it. If you go to the gym and you jaw jack for an hour a day, and 2 years later you don't look any different than you did when you first went in the gym, you can't blame the gym. And I watched the same thing happen in college. I watched these group of, it doesn't matter, but there were 2 women who never learned anything the entire time I was in college. In fact, it was so bad that they sued the college afterwards. And I'm like, wait a minute, I went to the same college you guys did, but why did I learn a whole bunch and you didn't? Well, because I didn't cry about stuff every single class. Every single class they asked the teacher to explain this, and I could not believe it, but he indulged them every time. I would never do, in my college class, I would never do this. I'd tell them, look, I've explained it to you twice, go read your book. That's exactly what I would tell a college student. I'd put that in an email. You're not even gonna fucking study this stuff, and you're gonna try to, like, come in here and be like, teach me. Like, you're not even gonna listen, and you're just gonna sit there and act like, you know. I'm not saying you guys. I'm saying in general, like, people act like. Anyways, 128. That's definitely one of them. 16, 144, 192, 32, 160, and 208. So let's go look at these real quick. Are those the numbers that we just popped up? That's it. They're all there. All the numbers. Yeah, jaw jack. Yeah, oh man. You have no idea. When I used to go lift in the gym, and there'd be guys like jaw jacking off to the side. We call them jaw jackinators. And they'd try to come up and talk to you and be like, oh, hold on, man. I'm here for like 45 minutes to like lift and, you know, get strong. I'm not here to talk, right? These are the same guys, by the way, who will make fun of you for wearing gloves and stuff. I wore gloves the entire time I lifted. I weighed 180 pounds with a 400-pound bench. I was perfectly fine with anybody saying whatever they want. My squat was a little over 7, and I weighed 180. So like it's anyways, it's ridiculous. People people focus on the things that don't matter. I always tell you guys that about engineering. Like engineers, even people do it in engineering all the time. They focus on the thing that doesn't matter, and it's like that thing doesn't matter. Why are we talking about it? It's such a negligible thing to the engineering or anything. We call it, by the way, in engineering, we call that, for anybody that hasn't been around, we call that bike shedding. If you've never seen the term bike shedding, it's also called the law of triviality. So, and Parkinson's law of triviality redirects here, not to be mistaken with Parkinson's law, which is, but the law of triviality is it works like this. Bike shedding works like this. You're building a $4 billion power plant, but people want to argue in all the meetings about the $10,000 bike shed out front. It doesn't matter. Like, and engineers do it a lot. I find engineers do it a lot because they don't want to get to like, I even find like I'm doing it here. Like you do it because you don't want to get to the stuff that's important, right? It's almost like you caught me monologuing. Bike shedding is just this dumb thing that engineers do. And the best way to deal with it, this is from years of me doing this and also from everything you can go read about it. The best thing to do when two people start bike shedding in a meeting, because it's always the same engineers that'll do it, guys. The longer you're on calls, you're going to say, these two guys are bike shedding again, or, you know, I don't want to, typically guys in engineering calls, but that's just the way life is. That's not because it should be that way. Who knows? I'll let you guys go deal with the philosophy of it. I'm just going to tell you, the guys are probably going to be sitting there and they're going to start bike shedding, and the best solution, hands down, is to call it out. Guys, we're bike shedding, and then get back on track, because people will go off on a bunch of different shit. All right, the question here was earlier, it was, how do you do, so now that we've got these things, the question was, what do we do with our subnets? So you're going to see over here, if you're not familiar with AWS, what I have here is a VPC, which is my virtual private cloud, and I've broken it up over 3 regions. Region US West 2A, US West 2B, and US West 2C. So those regions are about 100 kilometers apart at a minimum. They are their own power, space, and cooling, meaning if something were to happen regionally in an area, even though regions are a different concept, I'm just saying the term regionally, they wouldn't affect a different one. So what a lot of organizations will do is they'll make sure, for redundancy, that they've got something in each of these different areas. So I've got a public, a private, and a private in US West 2A, a public, a private, and a private in US West 2B, and a public and a private in US West 2C. So the question earlier was about where you would put load balancers. My load balancers would go to my public subnets here. And typically, because I don't want any one outage of a local area touching any one of them, I would probably set a load balancer. This is actually perfectly acceptable architecture. I could have a load balancer in each of these areas, and that load balancer could actually be reaching back to all of the same instances in any of these private subnets, even across regions. That's perfectly acceptable. So you could have 3 load balancers out there in 3 different availability zones talking to all the nodes. And then you say, well, Scott, how do I direct people to each of those load balancers? Well, that is done through Route 53 DNS. So Route 53 DNS can give a multi-value answer to any of those. It can also give a weighted answer based on geography, lowest latency, all kinds of things. You can do all kinds of stuff. Hey, Submit Jerome, thanks for coming back. Actually, it says your first time chat, but I swear I've seen that name before. Hopefully this stuff's useful to you. We kind of got off track. Again, I'm doing networking, right? We don't even normally do like networking. I'm not even on Saturdays normally, but I hopped on early because I got to do my college stuff because I'm going to college, and I have to do my college stuff because I teach college, and then I also have to get something ready for my presentation next week for work. So I'm kind of sitting here messing around instead of doing that. I'm kind of doing my own bike shedding. Glam Shatter School, thanks for the Prime. You could use that anywhere, and you use it here. I always appreciate that. Helps keep me motivated and stuff. Um, but guys, yeah, this is kind of the way that it works out in the cloud. Now, what we were working on was over here, and we were looking at how these networks. These are my networks inside of my thing. What class am I taking? Teaching. So I'm teaching a CEIS 310, which is process improvements, and as part of that course, I'm doing a lot of Six Sigma. So I'm constantly getting you guys here. I actually just updated this earlier today. I'm trying to get you guys to do the Six Sigma stuff because, like, we were talking about this earlier. Like, what do we do to get into the industry? If you have a hard time getting into the industry, just start going and getting free certs. So there's 2 free certs there. There's the API Academy one and the Six Sigma one. Both of them, the actual testing for the white belt, which is the basic one, is free. Glam Shatter School, I do teach subnetting, yeah. Yep. My other class is Networking 191. Those are the ones that I'm teaching right now. Network 191 is like a intro. It's actually called Intro to Networking, and I teach that in like a cohort online with like 10 other instructors. It's actually kind of, I really like the modalities that DeVry has gotten to. What it is that class there's like 600 students in it. You say 600 students, it's an online course, so they can be anywhere around. But this is how it works. There's like 10 instructors, so every instructor has between like 45 and 60 students that they grade their stuff for. Hold on. But then we all come together one night a week and we teach. And we talk, and each instructor has different blocks of time. I had a 50-minute block of time this last time. So we've got all these things that we're doing. And then we have our huddle sessions throughout the week. Like, I have a huddle session in about 4 hours here where I'm going to be down there, and any student from any of those classes can come in and talk, and I'll pull this same stuff up right here and do networking with them. I've been teaching networking like this for 15 years. This is the way that I show people networking. Okay. So for you guys that were around when I was doing it earlier, there's that. Yeah, I definitely teach subnetting. And then the other part of the question is what class am I taking? I'm taking a it's BES 815. So it's like intro to research, but for my doctorate program. So I'm working on my doctorate now. I finally decided to go that route and round out my education. I don't really care to do research though. Just, being fully honest here, I don't care that much about the research side of things. I'm an engineer through and through, but I respect the process and I'm good at playing the game. And I tell people all the time, like, I don't have to respect a game to play the game. And I'm not saying I don't respect research. I'm just, there's so, like, when I read research papers and it's like in one sentence, one paragraph this big, there are like 13 references to other documents. I feel like we're stacking up like houses of cards, and we're like assuming and codifying down that what they're saying was accurate. And it's like nobody's ever going to follow all those links to read your stuff, because your paper would go from 60 pages to like 30,000 pages. There's no effing way in hell anybody's going to read everything. So knowing that, we're just assuming that that's all accurate. And I'm used to, as an engineer, I pull the information direct. Like, if I tell you that US West 2A is a 10.10.0.0/20, I am 100% sure that that is true and a fact when I send that off in an email to a company. But in research space, it's almost like, well, some other guy referenced that it was true, so it's true. So, okay, I'm not going to try to, like, shit on the process. I'm still new to it. But again, I could play the game as good as anybody. I'll be perfectly fine doing it. It's just I'm going to be sitting there the whole time like, I don't want to do this, right? All right, anyways. Bottleneck said, I'll always wonder how doctorate programs in IT work. Bottleneck, mine is, it's funny, my master's is, I have 2 masters, but one of them, the most recent one, is in engineering. And it's funny, the most recent one is 12 years ago still. But anyways, God, I'm so old now. But the doctorate program is not directly in IT. It is in quantitative analytics, but it's a business administration. So I'm going to focus on teaching engineers. And I'm going to focus on teaching engineers, and probably, like, I'm still working on what my dissertation topic is, because, again, this is my first class. But it's going to be around retention rates and training your engineers. And I'm going to, because I've worked at a lot of different places. I do contract work, and then I also teach. And when I say I do contract work, I'm a full-time employee of Redline, but they contract me out to different things. So I get to assimilate and work with a lot of different teams. I end up training people. I build training. I do all this stuff. And I really think that engineers get to a point, and some of you guys aren't going to believe this, but this is kind of true. You're going to get to a point in your career where the money isn't the most important thing anymore. And now I know people aren't, especially starting out in your career, you're not going to believe me on that. But there's going to come a point where it's like, hey, for 25% more, I won't just jump out of this company. I'm pretty comfortable. I like the work I'm doing. I feel like I'm making an impact in the world. Like, there's all these other things that are going to start to factor in to you as an engineer. This just happens. And one of the things is almost always personal growth. You'll see people all the time on exit interviews as engineers go, I just didn't think I was learning anything anymore. I actually know. Well, let's say I don't just know. I could probably pull off the cuff like 20 engineers I know who leave their jobs every couple years just because they feel like they're getting stale where they're at. That's a thing. That really is a thing. That's a huge thing in engineers. I mean, you're dealing with people typically that have tremendously sharp memories and they love solving problems, but you can only build so many networks like this before you're like, I know exactly what's going to come out of that machine. Like, and then you want to move on to something else. And some of you, obviously, early on in your careers, you're like, hey man, I just want to feed my family. I remember that when I was younger. I remember that. But I'm going to tell you, you're going to get to a point where it's like, hey, you know, I'm at 160 right now, and I'm pretty comfortable. They're offering me 185, but I'm going to have to like get into a whole new system. I'm going to be in a higher pace. Like people always talk about like getting into Fang. Fang is great in your 20s, but like we have some guys, and actually if Sending ever comes on and talks, he's in Fang. One of our other guys that streams pretty often is also in Fang, and they'll tell you like this is extremely stressful even if you're very good at what you do, because you have to be a high performer all the time. Even when you move up to that next level, now you got to be a high performer at that level, or basically you've reset yourself back down. And is it good pay? Absolutely. But is a 10% pay bump for me? Because going to Fang wouldn't make me very much. Actually, I don't even know if Fang would make me anymore. But anyways, the point is, I wouldn't want to do it. I don't want to be in a high-speed environment. I get to do high-performance compute with a bunch of different government agencies, and I get to kind of chill, and when anything gets difficult, I get to just train new engineers on it. So it's like, yeah, it's huge. It's huge. It's where I'm going with that, though, is like, as engineers, you're going to find quality of life very quickly becomes a thing. So that's probably going to be what my dissertation originally goes towards. It'll be training engineers and retention rates and that kind of stuff. Because most of you that have been around know that I've been a platform engineering lead for many years, the last 10 years, and I've also been the red team engineering lead for organizations. And the red team lead is the offensive security, right? We do all the offensive security for, you know, how attacks happen and how, and there's a lot to that. Like people think like, oh, you just do pen tests and you just sit around all night in your hoodie going hacker man. That's not how it is. Like that's such a small part of what that is. In fact, most people that have the mentality to be a pen tester actually really dislike the work of pen testing. That's why you'll find a lot of guys say, hey, I want to go do, I want to go do like these bug bounties where I can just like kill a system and move on. But even with bug bounties, the write-up part of it is what probably stops most people from doing them. So there's two part. Well, I could pull it up, but there's three things total that go into like a good engagement like that. You've got the pen test in the middle, but there's all the planning before. What's in limits, what's out of limits, what, you know, are they allowed to take the system down? You're going to pay somebody to take your production system down? No, you're going to limit them, you're going to scope them down in some way. And then they do the actual work, which is wonderful. You know, they can test your system, they can find stuff, they can pick at little areas and identify things that haven't been patched and things that actually truly are vulnerable. It's awesome, right? Then they got to write a report, an actionable report, and people hate that. People absolutely hate that. Tell me that like a guy who likes to solve puzzles, right? A guy who likes to go pick at information until they figure it out and do cryptography and all these other things. Tell me that guy wants to sit down and write a report for people that aren't even going to understand what they did. You know, and an actionable report at that. Like, these are the things that need to be fixed, enumerated by... Most people don't want to do that. And that's where the value is for the business. So it's like, I tell people all the time, like, as engineers, we like to solve problems and do things, but then also the other side of it is you've got to make it something that's useful for a business. Like, I would love to just go to every Linux system I could, push the gas down as hard as I could until the system crashed into a wall and go, that's as fast as that system can be. That's interesting. Oh, can we streamline it down and make TCP work better so that we can send packets faster? Sure, yeah. Can I squeeze every last little bit out of it? But nobody's going to pay me to do that. I mean, I've been on high-performance compute systems all over the world. The number one thing that they want is stability. The speed is baked into the building of the system, and yeah, if you're underperforming on speed, you'll fix it. That's a value. But like for me to just sit around and tweak the system to get like 3% more speed out of it, most people aren't going to pay you for that. Active note taking makes reports a lot easier. Yeah, and I show you guys all the time. I pull up Notepad, and I do notes in real time. I like Notepad++. I've been using this one for years. One of the reasons I like it so much is the dark mode. And you guys that have been around have seen me use this one for years. Here's my questions for HPC engineer. I keep all kinds of stuff in here, especially when we're doing stuff here. When I'm asking you guys questions about being a Linux engineer or getting into that space. And then when I ask you guys about, this was the security engineering questions that I'd ask. We did this a while back. I don't even think I ever finished this. I finished it long ago, but not recently. Anyways, so active note taking is big for me, Bottleneck, because then I go back and I just pull all the stuff in and then I send it as a report or whatever. So, all right. So what were we doing? We were, looks like the wife's got the back door open. You guys might see the wife. She has decided to go out back, and Ranger's laying here on his other bed. But again, our couches got taken. Our couches, we moved them in the other room. I showed that earlier today. And then all of our monitoring. I need to get back to, okay, so let's go here real quick. If this stuff doesn't make sense to you, we do have a YouTube. You got to go find it. Well, here's the YouTube. You don't need to find the YouTube. There it is. But in that channel, there's one called the Networking Primer. And I walked through all of this stuff. We did a few hours of primer on networking. Let's get that out of the way. Let's get this out of the way. Get that going. The thing that I was working on that I need to get back to, we'll get this out of the way. This is the whole network primer, by the way. So if you're like, I want this, I want to go over this. We got that. Colkis, ask me whatever you want. I will. I'm going to keep working on this, but I will answer whatever you ask me. In fact, I was answering a question there. I'm over here and I'm building out stuff. This was the other day we were going through getting into the cloud and how an organization can move over there. So I'm putting together my training on that, basically. All right, so quotes get you interested, topics, and then terminal course objectives. Let's go understand the basic how to move quickly into the cloud. How to understand where to go for architecture of cloud services. Understand the tools you have that are available to you. Out of scope technical discussions, technical constraints and capabilities of the cloud. Let's say technical limits and capabilities of the cloud. There we go. So Colchis, that's an excellent point. A class A, like if I went to my home router and I picked a class A, I can start on 8. In the cloud, you can never go past 6/16. The cloud, the AWS, their VPC documentation, they never let you go past 16. So that's an excellent point. The point he's making is right here. I don't know. But the point, hold on. Let's see if we have it here in the docs. The cloud will never let you go past /16, so you can never go bigger. That's the biggest you can get out there is /16. But could you in your internal network do a /8 and then have everything be yes, yeah. In fact, let me show you. I'm gonna link this for you guys. But then let me show you guys the subnetting scheme of a school district that I worked for many years ago. I worked for a school district, and this was our. Let me pull up that subnetting. Pull up our subnetting template again real quick. Hold on. This was the scheme that they chose. Hey, thanks for the follow. Hopefully this stuff's useful to you. Let's see. What was that? Charlie VAR. Hopefully this stuff's useful. All right. I'm out of monster. Real quick, this is a schema that they used. And just to show, oh man, where'd this go? Hold on, pull this up real quick. Get out of here. Oh, I'm grabbing the wrong thing. Here we go. Let's do this real quick. Just to show this. When you say you don't go past 16 means low. Yeah. So with the class, if I have a 10.0.0.0 in our network, in our home net, let's go here. Nope. Here. In our networks, we can go over here, right? But in the cloud, they will never let you go past here. So in the cloud, this would be carved right here, 10.0.0/16. That's a cloud limitation. That's something AWS chooses, because then you can have at most 65,534 hosts total. Yeah, the smaller the number, the more IP is available. Fair, yeah. So they put you over here, so they only let you have a room this big when we're back in my example of rooms. But if you did this like in your home, if you have basically any Netgear or Asus type router, I got an Asus router here, I can change my network to a 10.0.0.0 with a /8, and I can have this. So this is 65,534 total usable hosts. It's to the power 16. This over here is 16 point something million. This is a huge address space, but they won't give you that in the cloud. The most they'll ever give you in the cloud is this. But you can just open up a new VPC. So in the cloud, you could have a 10.0/16. You could have a 10.1/16, and each of those are this big. Each of those are that big. And then you could have a 172.16 and that's also that big. And then you could have a 172.15. And that's in a different subnet. And that's also that big. And every one of them, each of your VPCs can be that big, and there's no conflicts between them, which makes your routing a million times easier. If you always pick this one, which is, by the way, the default, 172.16, or the one that they gave me, which was 10.100, if you always pick that for all of your VPCs, don't be surprised if you have to really finagle some stuff to get you can still get your networking to work, but you can't directly peer them anymore. There's some problems there with your routing tables. But if you do not have them peered, but you're connecting them a different way, since you're NATing everything, which is network address translation, you can get away with you could have the same internal all the time. You could do that. But then you have to NAT, and you can't internally route, and you can't do routing precision, because you have to say, okay, I accept that is that address to that house. Now I'm no longer able to go to each individual room from over here. I can just go to the house and have that house, the person in charge of the house, control the networking inside. So can you also have 11.12? Yeah. So yeah, let's say in your home network you wanted an 11. Absolutely. Hold on. Yeah. So what would an 11 be? So this is why we have to be able to do this math, because I have to figure out. Let's say I did this and I had an 11. So it's a class A by default over here. That's 8 network bits. And then 11 is 1, 2, 3 subnet bits, right? So here's my subnets here. This becomes a 0, 0, 0, 0. And I come over here to my thing and I say, okay, we got 8 usable subnets. And then my host bits are 16, 17, 18, 19, 20, 21. So I have 21 host bits. So you were going to ask me, the next question you're going to ask me, everybody would ask, is what's the next, how many hosts do I have per? And I tell you, I don't have 21 over here. So what I got to do, because this is the quickest way to do it, is pop over here, go to the old Googles and say 2 raised to the 21. And I have, that's 2,000,000 2,097,150 hosts per network, of which I have 8 networks. So each of these networks here has 2 million and some change. 2.09 million usable hosts in each of these 8 networks. So yeah, you could do a /11, and then the networks that you'd be counting on would be on 32s right here. So you'd have the 10.0.0.0 network, you'd have the .32 network, you'd have the .64 network, the dot whatever, and then everything underneath it would just be some address in that space. And it doesn't matter. Again, I keep telling you guys, it does not matter what you throw at me, or what you throw at an engineer. The problem just ends up being, can I move it into this? And after again, the reason I show you guys this tool, the reason I use this tool like this, is because eventually you don't need the tool anymore. Eventually, with some of the big numbers, you still do. Like I didn't know this number off the top of my head, guys. But most of these ones you could probably figure out pretty quickly. And by the way, I could have kept doubling that, and I would have found that number eventually. But again, it's easier to just toss in the Googles, right? The old Google machine. All right. So hopefully that answers that question for you guys. And then other than that, again, guys, I'm not normally even on Saturday mornings. I'm just kind of messing around before I get ready for my college class here. Actually, I don't even have to get ready. I've taught this class so much. But I'm cleaning up this documentation, or this thing here. Oh, whoops, I want to undo that one, because I'm going to do that, and then that, and then that, and then this can go here, and then pull this back up. I can get this out of the way. We don't need my VPCs right now. What was our pieces here? So initial setup of the cloud, focus on quick wins and long-term strategies. So this was initial setup of the cloud. Of the CLUD. No, we don't need the CLUD. Okay. Initial setup of the cloud. The next one was focus on quick wins. Yep. Focus on quick wins. Focus on quick wins. And then the last one was long-term strategies. This is what I end up doing, guys. This is it. This is my life. All right, let's craft this. I'm gonna make this a little easier here. That song is supposed to sound like it's sleeping, I think, but it just sounds like it's farting. I don't know if you guys can hear that or not. I imagine you guys can. I gotta change this one. The Assault by Dark Fantasy Studios. Let's see how this one sounds. This one might be fun. I'm cleaning up my stuff over here on my side. Windows, I don't want to go to that. It's garbage. Let's go here. So, intro to cloud topics. We got that one. Focus on quick wins, and then these are going to be my sub points. Start doing what you're not doing. Let the cloud come to you, and then analyze workflows. So maybe I'll add that. I think I'll add those here. Focus on the quick wins. Yeah, maybe I'll do those here. So I'll duplicate this, and then first one will be start doing what you're not doing. This one will be let the cloud come to you. Okay, and then this one will be analyze existing workflows. A little more labor intensive for some of these. There we go. Alright, that's good. I think that's all I need for that, so I don't need that drawing anymore. Good. Alright. So, could you post a blank slide in Discord? Yeah, Colchis, it's actually there. Can I show you this? If you guys go, if you want to work through, I was telling you guys how I stole Ranger's couches and put them in the other room. That's why Ranger doesn't have his couches all around him anymore. That was from last night. But if we come over here, yeah, go to if you go to networking topics, I used to do these all the time. By the way, um, I used to drop these in here all the time. But here's some questions, and then if you wanted to go back and work through some of our older versions of these, I do have the slide deck. We're talking about war driving. There's all kinds of stuff in our Discord, guys. If you go back a little ways, hold on. I assure you it's in here. This was me working with my students, but hold on, I have it dropped in here, just as an actual. But you can find them as questions up here too. Hold on. I know this isn't the most efficient search, but there's not that much in the networking topics. People don't talk networking so much in our server. This was an explanation and a question that I had, and I used to give the questions just like this. So here's one example of it. You know, I'll copy this out, copy image. I'll just redrop it in here. So there's that, but that's not the base one. These were just questions I was asking before, and then the base one, I think, now that I think about it, is down here in presentations, maybe. HPC topics, solutions, architects. Here's it's a subnetting template. Colchis, it's right here. So presentations, here, and then I think, can I reply to that, and then just at. I think that's Colchis. I think that's you. I can't really see because it's the mode so that it's kind of like protecting your identity. So you guys can't I couldn't see 100% if it was you. It had a message link to copy. Oh, did it? Yeah. Whisper, I could have done that too. Oh yeah, I guess I could have done that, huh? I didn't even think about that. Come on. Copy message link. So if I post this down here, I don't know if this will send you guys, like this will invite you to the Discord maybe, but the Discord's open for anybody, so I don't have any limits on Discord. But I think if I click on that, it'll try to get me to, so I can jump in. But I'm already on Discord, so I don't need to do that. All right. Yeah, but that for anybody, that's basically the same as just doing an invite here. You guys are always welcome to join the Discord. We got a bunch of engineers down there. We're over 900 people now, so that's pretty nice. You know, that's pretty big. I mean, my initial goal was to get us to 1,000 by August, but we slowed down a little bit. I wasn't doing as much streaming earlier this year, and then like my goal now too is just really to get people into the industry. Like the whole point of all this is to get you guys into doing this, whether you do it in the Linux side, whether you do it on the cloud side, whether you go and you learn Linux so that you can go do programming on it. I'm not going to tell you guys how to do this stuff. There's a bunch of stuff out there. We do have labs. I talk about labs often. We have labs that are available for free up on Killer Coda. I've got 54 of them now. They're 100% free. You just log into Killer Coda and go do the labs. They're very hands-on. They very much show you how to do Ansible, HashiCorp, Kubernetes, and Linux. I would focus, if I was a beginner, on Linux, because I think that's, Linux is how we, do this stuff. So, yeah, bottleneck. The whole goal of this, again, I've been doing this stuff a long time. The goal of this is to reach people who, honestly, like, I tell you guys all the time, if you look at my background and say, this guy's got a lot of school, I didn't do Linux in school. I had one Linux class in college. Most of my college students now get like at least 4 classes where they're touching Linux. I had one. You need to Whisper. Yeah, we did NixOS on here before. I think I built a little NixOS. That's the one that's I believe. Yeah, NixOS is the one that's it's immutable, right? Is that it? Yeah. Yeah. Everything will always work. Yeah. I haven't. You know what? I might play with this a little bit for our lab environment because I need to get a lab environment where everything's just always the same and I just blow stuff away. So hand so high. Let me tell you a story to answer that question. So the question, guys, is Linux a technology that will stay forever relevant? Let me explain it to you guys this way, or let me say it this way. You declare the state declaratively like Terraform. That's pretty cool. But hand so high. Let me answer your question real quick. When I was on the NOAA project in 2020, I was 39 years old. I was 39, 38, and turned 39. And then I had, while I was on that project, I had a grandson. So I got a grandson now. Before I turned 40, so that's like a life achievement unlocked, right? But hold on, where I'm going with that is this: when I was 39 on that team of Linux and Unix engineers building out stuff for NOAA weather, I was the junior person on that team. If I took the average, if you took me out, took my 39 years old out, and you took every other engineer on that team that had been all Unix and Linux engineers. Most of these guys were before Linux was a thing. They were Unix engineers that were on that team. I brought the average down, and I was 15 years younger than the median age. So I was 39. The average guy on that team was 54 or older. The average was right at about 55. So where I'm going with that is, yes, I think Linux and Unix style systems have been around for a long time, and I don't see them going away. And people are like, well, but we've got these AI systems, and soon we're just going to have AI managing all our servers. And I say, AI can do some really cool things, like these language learning models that look like you're talking to a real person, and they go out and search vast amount of data and give you, data, and give you a lot of good answers around information. But they never are super precise, and they never give you the real right answer for a lot of stuff. Yeah, I think Linux is going to be around well after all of those things are implemented and that kind of stuff. Yeah, I think of Linux as the piano of engineering. Linux is like the base thing that I think everybody should start on. Oh, and then you want to go be a front end or a back end developer? Sure, but have Linux as your base. You want to be a platform engineer like me and build systems and connect to storage and do networking and stuff? Yeah, but Linux is the start, right? So I always think Linux is like the underpinnings of everything. Oh, you want to go be hackermans? Like I always joke around about everybody wants to learn how to hack, but nobody wants to learn the basics. Hackers all start in Linux. First thing they do is go download Kali, right? So you got a command line, and understanding these things will add like a tremendous amount of power. Yeah, Colchis, at the end of the day, it's and this is very apparent when you look at people's hands on there. AI is just, it has no back-end knowledge of what it's doing. It's just trying to give you what the model thinks looks good based on all these other things, but it has no underlying knowledge of like what a finger is or how it works, right? One of our guys, let me give a shout out. Earlier I mentioned Sending Grounds. But one of our other guys, Fisherman, Guy Bro. I think that shout out should work. Yeah, if you guys follow Fisherman, he uses it as like a junior solutions architect, because he does solutions architect work. He uses it to like go and answer questions for him, but then he knows he's going to have to check the work. He knows that it's not a finished product that's just going to go in a system and work. And back to the point of engineering that we were talking about, I tell you guys all the time, if systems worked out of the box without anybody needing to set it up, like if you could just set a solution up out of the box, the salesperson would do it. Why would they need us engineers? They need us engineers because when we go to implement something into a system, we need to properly attach it to all of the inputs and outputs of other systems. That's, yeah, if you guys don't follow Fisherman, he does really good work. He doesn't stream as much, but he's busy, so he's a busy guy. But he's, and he also just got his 6th AWS cert. So 6 of the 12 he's got right now. I've got 5 of the 12, so if you guys keep track of our golden jacket stuff, right? Or our certified, my favorite one. He's got 6 of 12 now for AWS. But he works for AWS, so I'll give him that. I only have 5 of the 12. I don't know how much time I'm going to have to study for those with doing all my research and stuff, my research projects and stuff. But all right. Anyways, let's come back over here. Let's go back to our document and let's keep putting data over. So this one, you guys have this. You know where you can find that. If you want that, that's up in the cloud. Yeah, I love the do all the Linux one as well. In case you guys don't know, that's the only the do all the Linux, the burn in, that's the only thing I know how to do in GIMP. Like, I can put some text in GIMP, and I can do a burn in. Which is, by the way, why this, and this, and this. Wait, no, it's not on that one. I don't have it on that. I can do it there. It's there. The user. So I know how to do, like, that's it. Yeah, GIMP is such a cool little tool. I can do some other basic things, but yeah, like, I don't know how to do, like, hardly anything else. Well, and by the way, when we did our golden jacket, so there's a thing here. I'll show you guys. If you guys didn't know, this is another fun reason to join our server. In the certifications channel, one of our guys came, and it's King Buns. He came and talked about how he did this. But if you guys have never been in our certification topics channel, I built this. I took a jacket drawing from the internet, and I put a puzzle over it, and we turned it into the golden jacket. And it basically represents how much you are of the golden jacket, and then we added these terms to it. But one of our guys, King Buns, he went and he turned it into a bot, and the bot automatically colors it. So if you drop into our server and you say jacket, and then you give it the name of your security cert and all these other things, it will build your jacket for you. And he gave a talk on how he did it. He's a programmer, and I think he does some web stuff. But he came and gave a talk a few months ago back, on how to do this and how he built that up and how it plugs into that stuff and all that stuff. Yeah, if you guys have never seen that, these are procedurally generated. When I first used to build them, they were by hand. I would color them and do them for everybody, and he built that for us. So now, any of these you see in the channel, anytime one of us got a cert, I got my Solutions Architect Pro a while back, and then Augustus. Oh, here, Augustus was on earlier. When he did his, here's his. So he got his Certified Cloud Practitioner and Solutions Architect Associate, and it slowly fills up whichever ones you've got for your jacket, and I think that's super cool. And then look, yeah, there's Augustus. Who are the other ones? Yeah, you can't just put like sysops. You got to use the name of it. So there's some limitations on it. But Quartz 1, he got his CCP, Certified Cloud Practitioner, and they put it. They use a different acronym for it. But it was just super cool. One of our guys built this for us, and then he came and he gave a good talk on it for how that works. So here's one of our guys. Oh, so this was him, King Buns, testing it to show the different ways that the jacket could be. Be a nice post. Yeah. So actually, Whisper, this one has gone on LinkedIn. Yeah, we have. So I think my LinkedIn. Let me pull it up. Hold on. Oops, don't want that. Let's pull up my LinkedIn. I don't care if you guys know who I am. I've never cared if anybody knows who I am. I'm a real person. But let me see if I have. I don't know if I've ever posted that. I don't think I've ever posted that. Oh yeah, this is one of my favorite memes. I make memes like for fun. This is one of my memes. Linux engineers, Linux is easy. Just take the first step. There's your steps. I put this on. This was on our Discord before, but if you guys want to, I'll post it back up on the Discord. I don't think I have the golden jacket on here, but every time I've gotten like Solutions Architect Pro, when I got that one back in 5 out of 12, yeah, so 7 months ago. So I haven't been studying for my AWS stuff, but yeah, I should post that up and talk about that here. I'll post that back in general. Actually, I'll put that back up in Throwback because that's a fun one. Throwback is always where we put stuff. The time I made that meme. I think that's a hilarious meme, by the way. Linux is easy. Just take the first step. You know, maybe I should make that. I should make that the when people follow. Linux is easy. Just take the first step, and then the steps. It's like you get sick almost looking at that. So, get credit whenever someone posts on LinkedIn. However, more people on the Discord. Yeah, I'm really glad. It's funny. Sometimes I schedule the people to come talk. So we have more talks coming up, by the way, guys. We've got the ProLUG group later today. That's just us hanging out. There's typically a lot more than 2 people in there. We'll get like 8 to 10. Then Ben's coming to talk next week about analytics and economics. He's going to come talk about how you gather data, how you do research, all that kind of stuff for people that are interested. And then we're doing our ProLUG Christmas party on December 16th, which will all be virtual. I'll just be online playing around. We're going to do some kind of giveaways there. And then I think I have some things I'm going to do for like kind of the main community members that have been kind of helping out in our community. I got some mods and stuff that we should thank or whatever. This was years ago. I made this for a talk that we did on Ansible. I love Ansible. I think it's a great tool. I think it's like the most useful of all of the automation tools that I've ever used for systems engineering, for like systems engineering and platform design and stuff. But what can it do by itself? Not a whole lot. And the point I was making here, the discussion, had to do with moving into using Ansible with Tower. Tower as the orchestrator, doing the over here do this and over here do that. It makes Ansible so much more powerful than what it is. Yep. Colchis, if you're around Sundays, so tomorrow morning for Sunday, and it is the wife's birthday, so I might have to move the time a little bit. Sundays are all lab days. That's all I do on Sundays is labs. So you guys are welcome to come and do labs with us if you want. All right. Anyways, what was I doing? Analyze and move existing workloads to the cloud, and let the cloud come to you. Start doing things you're not doing. Let the cloud come to you. Boom. Okay. Long-term strategies. Secure a 3-tier app. That's old. Securing the application. That's also old. And then the review. The review for me is always the same as the topics. So I can grab this and go down to review. There we go. So review is always the same. And then long-term strategies. And then where do we go from here? I need to clean these all up then, which is basically like I have a slide typically when I do this, guys. When I give talks on stuff, I always do when I do my talks, I always give like places to go afterwards, and sometimes in this case it's going to be reference to what we do in the discussion, so I'll clean that up. And then questions, there's my information. That'll be for my Redline people so they can get a hold of me. Typically when I do this for the ProLUG, I strip it down and I just say message me on Discord, because the easiest way for you guys to get a hold of me professionally is just to do it on Discord. That's the easiest way for the ProLUG kind of to reach out to me. And that's ask me a question on there. And if you guys haven't seen, I have a clip. One of our guys clipped some stuff for us. And what happened here? Oh, I got to change the beginning of this. So this is quick wins and long-term organizational strategies to move workloads to the cloud. Okay. And maybe I'll do one of these for, if anybody's interested, maybe I'll do one of these specifically. So this is going to be like a quick wins, and it's going to be very generic, guys. But maybe I'll do one in the future if you guys are interested in this, because I feel like, or at least I get the hint from people in the community that you guys are interested in the high performance compute stuff that I show sometimes. By the way, that's up on YouTube as well. Hold on, IT. I'll answer that question in a second, Whisper. But also, I think that people like, well, Linux is the basic underpinnings, but then high performance compute is a very lucrative area. We have a hard time. My organization has had an opening for months on getting somebody into high performance compute. We need a senior high performance compute guy for one of our contracts. So we work on, trying to get people, and I'm trying to train people up, but I can only get, so I have to show you all the basics of the system and get you doing that. And then I need to show you the automation pieces and the storage and the networking. And then you're ready to start to piece it together into like a high performance compute type concept. So I think, though, I'm going to do a talk that kind of does the quick wins and long-term organizational strategies, but specifically for high performance compute, for specifically doing big data type stuff out there. And then another thing that I'm going to do, especially since I'm, training in college to become a researcher, right? That's what doctoral studies are, is learning how to be a researcher. I'm going to probably be showing cloud stuff around pulling data out with a data pipeline and stuff. And I've shown you guys that stuff on stream before. Can you pull data in from an API? Can you store it in an array somewhere? And then can you do it over there? Yeah, use it. Yeah, Andre, I actually have a Slurm lab. Yeah, have you ever seen our Slurm lab? Hold on. Killer Coda. I'll give you the link to this lab here in a second. Yeah, I show you how to install Slurm and use it. Yeah. Come down here to our Het Tanish channel. This is the link right here is exactly this, right? That's our labs. And then we go to Linux labs, and I'm gonna give you the exact lab. But I got a Slurm lab right here. Install Slurm on Linux. Boom. There's our lab right there. You say, can I install Slurm and do some basics of like, once you get this done, once you do the lab, you can then go do any like workflow you want between the two nodes. Yeah, play with it. I'm gonna do one in the future that shows you how to do OpenMPI. If I can install, if I can pre-bake it into the system, I will. If not, you'll have to build it. Building OpenMPI on these servers, it takes a while, so it's not a great lab. If I got to take 30, if I got to take 33% of the lab building the server up, that's not necessarily great because you only have an hour in these labs. That is one limitation, but hey, for free, just getting your hands on a lab, that's pretty good. You install all this, and then you build up and you configure, and then you do some runs, and then you do some batch runs. So yeah, learning how to do Slurm is definitely something I show you guys how to do. Slurm is only one tool though. There's also what's the one that we used to use? LSF platform LSF, which is an IBM tool, IBM specific. Yeah, Andre. Yeah, if you and I have a whole talk. Again, I want people to go to the YouTube, but I'm not like trying to sell it to you guys or anything. But on the YouTube, I have like a 2 or 3 hour talk that we did on HPC. So I have an HPC primer that walks you guys through like what you need to learn and know for HPC. So if we go here, I'll show it real quick. But if you want me talking about it, where the hell is it? It's called HPC primer. I need to like standardize my naming. Naming's the hardest thing, guys. Naming stuff's by far the hardest. But yeah, this was our ProLUG. This is our talk on high performance compute, how it works, the concepts, the technologies, the networking, and then I have a bunch of links in there. Yeah. So there's a bunch of this talk I went over a few months back, July, end of July. So I don't think it's up here anymore, but I did take the whole thing and copy it down and put it up in YouTube for people that wanted it. Again, I don't really like putting stuff on YouTube. I'm not a big fan of like, unless I like really clean something up and make it, persistent. I don't really like putting stuff up there where I'm just like telling stories and flipping out and going out on tangents and stuff. I don't really think that's professional. But on the other side of it, I'm like, you know what? If people want to learn this stuff, you're going to learn it regardless of if I'm telling stories about Iraq or something. I was an infantry guy in Iraq, so do with that what you will. Sometimes I lose it. All right. What else? That would be funny if I included the golden jacket right here. My golden jacket for the 5 times AWS. That would be kind of funny. Just have it like right over here. And then I could explain to them the joke real quick. That would be fun. Jokes aren't as good if you got to explain them, but I still think it might be all right. That might be fun. Hold on, let me tell me what you guys think of this. Tell me if this is too Chad for a business. Hold on. It's definitely Chad, but is it too Chad? Hold on, let me go find. I gotta go find my jacket, because my jacket, my certified AWS certification jacket is here. Hold on. Actually, hold on. I'll pull it over here while I'm looking for it. The last time I got it was back in, what do we say, April? So I gotta go. Yeah, when did I get my last cert? April, right? Hold on. That was when Fisherman got his security one. So, and by the way, guys, I think he's excellent for you to go watch if you want to learn this. This was me. Hold on. Yeah, that's mine. So, copy image. Let's see if this looks too silly. Obviously not like that. So, so when the talk starts, it would look like this. That might be a little. This might be a little silly, but maybe I'll get rid of it. That's all right. What do you guys think? Is that too silly or no? Let me. There's not enough people to do a poll. Let's see, our last poll. You guys wanted subnetting? We'll do a new poll. That'll be fine. Jacket or yes, no. I'm gonna give it. That's gonna be a 2-minute poll. You guys can decide. Do I put the jacket in there or no? And I will do whatever you guys decide. Do you guys think the jacket's too much? Thinking like, hey, some guy's gonna come talk to me in my organization because that's what it's gonna be. And is he, is that a bit too much? Well, I mean, I'm gonna explain the joke, I guess. You gotta fix that page. Oh, let me pull those things off. Oh man, it's on all of them. It's terrible. All right, let's clean that all off real quick. All right, we got one for no. Do we got any yeses? All right, and then I'm gonna keep drawing that up and keep going with that. This was the other day I was showing you guys how I pull information out and send it to InfluxDB. That's what this was. All right, what else do we got? Pull this off to the side. See if there's anything fun happening down in the Discord. All right. What else do we have here? Got this going. How's Ranger doing? Ranger's back on his little Ranger bed, laying around, thinking about what a hard life he's got as a guard dog around here. No, unless we have all. Yeah, that's interesting. Yeah. That's fair. Yeah, because you can't claim to have a golden jacket until you have all of them. That is actually true. I think that's fair. I think we just kind of did that, and obviously in the server we do it as a joke. All right, we had one vote for no. We had no votes for yes. I guess I get a vote, but I'll think about it. Think about what I'm doing. We'll keep an eye on Ranger Dog. All right. I've already been... Man, I can't believe I've already streamed for over 2 hours. I wasn't even going to stream today. Let's go to end of stream here. You guys are welcome to hang out and keep talking shop. You guys are welcome to come and hang out with us later. We're going to be doing Linux, and I think I'm going to work specifically through more of our Socratic method type stuff. But, one of the ways that people learn is to just kind of be inquisitive about things. And the whole talks and everything that we talk about and work on in this channel is supposed to be around how to get you to learn this stuff. So I want you guys to, if you're doing this stuff and if it's interesting to you, keep working on it. Let's go find somebody over on the Twitch side to raid. Let's go raid Pirate. He's doing stuff that's kind of fun. We'll go raid over to him. And I will see you guys. Anybody that wants to be around tomorrow is all labs. That's all we do on tomorrow is labs. Yep, and I appreciate you guys coming by, absolutely. All right, let's do the raid now. And
that's wild, dude. Really?